For today's objective, we're going to graph quadratic functions in the form of y equals ax squared plus c. And we're going to see if there are shortcuts for graphing this. For question A, you're graphing a linear equation. Remember what a y-intercept is, figure out your slope, and then graph your line. For question B, we're going back to the making a table of values. Let's see what the y-intercept is, and can 2 be used to help graph this parabola? So each graph has a parent function. So the parent function is the most basic of all your functions. In this case, the parent function is y equals x squared. You can tell the lowest point of the vertex is going to be 0, 0. And you can also find that axis of symmetry because it goes through the vertex. Notice that the a value in front of your x squared is 1. So if we go up 1 and over 1, that gives us 2 more points to help draw this graph. Our parent functions for a line are going to be y equals x. The most basic parabola is y equals x squared. The most basic absolute value problem is y equals absolute value of x. Here's our y equals x cubed, and a new one, y equals b to the x is exponential. So there are several types of transformations that we're going to think about. If we have y equals ax squared plus c, we're going to shift the vertex, which was at 0, 0, to 0, comma c. Because if you substitute let x equal 0, then the new value for your y is c. So this is a vertical transformation. It moves the parent function upwards. Now, if your c is negative, it moves it downwards. There's also a vertical stretch. So if we were to think about that a value, and if our a value is greater than 1, then it stretches up to 3 and over 1, whereas the original problem was stretch up 1 over 1. So it makes it a little bit skinnier. To make your graph a little bit wider, we want that a value to be positive and smaller than 1. So that would be, for example, up 1/3 over 1. It's going to make your graph wider. So if your a is less than 0, that's going to be reflection over the x-axis. Think about y for a minute. If I have y equals negative x squared, it takes all those positive values, which would be above the axis, and flips them to below the axis because of the negative. Now, when we see a negative 1/4, it's going to make a wide graph, down 1/4 over 1, and you will see a wider graph that's been flipped upside down. So we have a new vocabulary set: vertical transformation, vertical stretch, vertical shrink, and reflection. If we describe the transformation for example, 4, your parent function stays at 0, 0, but the graph moves down 4. Notice the -4. It's also a bit wider. Did you see that it was a bit wider? So 1/2. So it's a wider graph, and it moved down 4. So it had a vertical transformation of down 4, and it had a vertical shrink of 1/2. So as you look at example 5, 3 things are happening. We're going to have a vertical transformation up 6. You know that because of the +6. We also are going to flip over the x-axis because of the negative in front of your a value. So that is a reflection over your x-axis. And the last thing that's going to happen is we're going to have a vertical shrinkage, and that shrink is going to be, make it a little bit skinnier. The graph is going to go down 4 and over 1. Given our equations are in the form of y equals ax squared plus c, we're going to be able to graph without a table of values now. We're going to use these ideas of transformations in order to get our parent function, that parabola, in the correct position. So let's look at example 6. We know that we have a vertical transformation of up 6. 1, 2, 3, 4, 5, 6. So we're going to place the vertex at 0, 6. From the vertex, we know that our graph is going to go down 4 and over 1. So it made it a skinny graph. And also notice that the shape is a parabolic function, so put a curve around that edge. Oops, make it a little bit better. I want to make certain that we get our shapes in. There we go. All right, now for example 7, notice it's x squared, so immediately we should figure out the parent function is a parabolic shape. The transformation, we're going to go up 1. Now, the a value is 1/3, so the graph is going to open upward. We'll go up 1/3 over 1, and we will have our first values. We know it's a little bit fatter graph opening upward. For question 8, now we should be able to go backwards and find our equation. So as we look at it, you see that the vertex is going to be at 0, -2. So the graph was pulled down 2. Now, if we go up 1/2 and over 1, that's going to give us our 1/2 x squared minus 2. Just double check it if you want. You notice if you put in the number 2, your answer should be 0. Let's check. Is 1/2 times 4 minus 2 equal to 0? Yes. So we did a good job of writing the equation for example 8. So graph the following questions and then check some of your answers. Notice for number 15, you had a vertical shrink. Number 6, double check that your answer agrees, and then I've given you a couple of other answers. You have a great day.